Let's solve the following problem on isotopes. The first question is this. Naturally occurring lithium consists of 90% of lithium-6 and 10% of lithium-8. What is the relative atomic mass of lithium? Now, take note that the percentage of each of these isotopes in the naturally occurring lithium, we call it the percentage abundance, or we just simply call it the abundance of the what of the isotopes in the original atom. Now, the abundance of this first one is 90%. The abundance of the second one is what is 10%. Good. Now, I don't want to stress us while memorizing any formula. The trick to just calculate the relative atomic mass of this isotope is that multiply the abundance with the mass of the isotope. Remember, 90% is 90 over 100. So I will say first one is 90 over 100 multiplied by the mass of this isotope here is what? 6. Then plus 10 over 100, the abundance of this multiplied by the abundance of this one is what? Is 8. Then if I go on, this will give me 5.4. Then plus this is 0, this will give me 0.8. So 5.4 plus 0.8 will give me what? 6.2, which is the relative atomic mass of the naturally occurring lithium. That's how to calculate it. Next question. Two isotopes of chlorine, look at them, have an abundance expressed in the ratio 3:1 respectively. Find the relative atomic mass of the chlorine atom. Now take note of something. At times, the abundance will be expressed in percentage, and at times it will be expressed as a what? As a ratio. Now, if it is expressed as a ratio, the first step we are going to do is to get the total ratio. Get the total ratio. And what is that? 3 plus 1, which is equal to 4. Then to get the relative atomic mass is this. Take a look. This first isotope here has this first ratio here. This second isotope here has this second ratio here. Take note of that. Now let's go. How do we calculate the one for this first isotope? This is what we are going to do. Take this 3 over the total ratio 4, then multiply by the mass, which is what? 35. Now, did you get what I'm saying? Now, we are going to what? Say this 3 for this first isotope over the total ratio 4 times what? 35. Plus, similarly, for this second isotope, which is 1, you will now say over what? The total ratio then times what? Times 37, which is the mass of the second one. So what do we get here? 3 times 35, if you divide by 4, we have 26. Okay, 3 times 35. We have 26.25 plus this is 9.25. So this will give me what? 35.5, which is the relative atomic mass of what? Of chlorine. So we don't include the units. Next one. Analysis of the elements iron by a mass spectrometer shows that the natural abundance of the 4 isotopes of iron of mass numbers this and this are given respectively. What is the relative atomic mass of iron? This is very easy. We are still going to be using the same step all through. Now observe. See, for the first isotope, this is its abundance. It means that I will say for the first one, 5.8 over 100 multiplied by 54. That's for that. Plus this second isotope, which has this mass, this is its abundance. So I'll say 91.9 over 100 times 56. For the third one, similarly 2.2 over 100 times 57 plus 0.3 over 100 times 58. And that is it. So for the first one, 5.8 times 54 divided by 100. This will give me 3.132 Okay, the second one 91.9 times 56 divided by 100, 51.464 plus 2.2 times 57 divided by 100, 1.254 plus 0.3 times 58 divided by 100, 0.174. All right, so let me sum up all this. Then this gives me what 56.024, which is the relative atomic mass of iron. Next, the relative abundance, the relative atomic mass of element Z is 10.2. If the elements exist naturally in two forms given as this and this, calculate the relative abundances of the two isotopes. All right, here now we have been given the relative atomic mass. We are now asked to calculate the abundance of each of the isotopes. Remember, I want to get the abundance in percentage, so I'll just say let the abundance of this first one be equal to X. And remember that what the total percentage is always 100%. It means that the abundance of the second one is equal to what? 100 minus X. Remember, total percentage is 100%. So if this take X percent, the second one will be what? 100 minus X percent as required. So let's go. So remember that the relative atomic mass now is 10.2, which is equal to, now observe, we are still going to be applying the same method. The abundance of this one is X percent, so I'll say X over 100 times the mass is 10 plus the abundance of this one is 100 minus X percent, which is over 100 times 11. So what do we do here? We have 10.2 equal 10x over 100 plus this will give me 11, 100 minus X, then all over 100. For me to cancel out this 100, I'll multiply through by 100. So observe, if I multiply through by 100, multiply through by 100, multiply through by 100. So this will take care of this. So I'll be having 1020 equal 10x. Also, this cancel this. So I have 10x plus, check it out. If I use this 11 to open up the bracket, I'll be having 1100 minus 11x. So what will this one give me? 1020. Bring this to the other side. This minus this will give me negative x. So 1020 minus 1100, that will give me negative 80 equal negative x. So if you cancel negative on both sides, x equals to what? 80%. So the abundance of this first one is 80%. If the abundance of this first one is 80%, it means that the abundance of the second isotope will be what? 100 minus 80, and that will be what? 20%. So that if you find the sum, it will be equal to 100%. This is how you solve questions of this kind. Next question. Naturally occurring. Okay, let me give this as a task. Okay, do it as a task and comment your answer below. Next question. This is the last question. Look at the question of this type. See, this is another way you can be asked question on isotope using the mass spectrometer. Now, take note that, see, this first one, we have 1.5. This one, we have 23.6. This third one, we have 22.6. While this fourth one, we have 52.3. You see, the peak height represents the abundance of each of the isotope, while the number you see below here represents the masses of each of the isotope. I'll come again. The abundance, all these are in percentage. Okay, so it means that for me to get the relative atomic mass of lead, it will be what? You see this 1.5, I'll write it as 1.5. Remember the percentage, so that's 1.5 over 100 times 204 plus here 23.6 over 100 times 206 plus 22.6 over 100 times 207 plus 52.3 over 100 times 208, and that's it. So just use the percentage to multiply the mass, and if you sum up everything together, you should be having something like 207.24, and that's the relative atomic mass of lead. So that's that for that. So thanks for watching. Like, comment, share, and subscribe, and click the notification bell so when I release any new video, you'll be notified. Thanks.